Righty, so let's just do a bit of a recap of what we already know. So guys, remember what's really important with equations is that we're using those opposite operations or inverse operations. Okay, so I feel pretty confident that you guys could have a go at question 1 and do this quite easily. So I'm going to wait in the chat and see who can give me an answer for question 1 here. So we've got x plus 6 equals -3. And if you're joining us, don't stress, I will explain it. But if you were here last week, we did have a chat about how you can do this. Remember those inverse operations. I'm throwing you in the deep end.
You can do this. We are my people. You guys are my people. I know you can. Let's go. Wendy, I see you. I see you, girl. Let's concentrate and do this. Muradi, are you trying it? Reabetwe, Kelly. You guys are my people. All of you.
Nice, guys. Yes, yes. Nice. Good answers. Okay, so quickly, remember inverse operations, essentially the goal is to get x alone, so to solve for x, which means that I am having a problem with this +6. I essentially need to get rid of the +6. For me to do that, I need to -6. I need to do the opposite. But if I'm going to do that to the left-hand side of the equation, I also have to do it to the right because I have to keep this equation balanced. I have to keep both sides equal to each other. And so x is equal to -3 minus 6, which gives me that -9 that you guys have so wonderfully put in the chat there for me. Good, well done. So let's have a look then at question 2. Okay, so question 2 a little trickier because we've got a few more terms that we need to deal with, but let's have a look. So we've got 10x plus 5 minus 9x equals -5 minus 3. Now, there's a couple different ways you can start your approach to this. What I would suggest is always just double check and see if you can simplify either side of your equation. Just because if you can simplify, it means that you're adding or subtracting your like terms. And so it means that you're just working with less terms overall. Okay, someone asked for a screenshot of question 1. So there we go, have a screenshot. Okay, right, let's look at question 2. So I can see that on the left-hand side, 10x and -9x are actually like terms. So what I'm going to do before I even stress about starting to solve this equation is I'm actually just going to subtract the 9x. So 10x minus 9x is just x, or 1x if you want, plus 5 equals, and again, I've got like terms on the right-hand side. So -5 minus another 3 is actually then -8. And just by simplifying, I've actually made this equation so much easier for myself. Because now what I can see is that I essentially need to deal with this +5. In order to do that, I do my opposite operation. So I -5 on both sides. And so what I'm left with is x is equal to -8 minus another 5. And so x is equal to -13. And so if you can simplify, sometimes that's just quite useful because it just makes the equation a lot easier to deal with. Okay, if you hadn't done that, that's also not the end of the world. You will end up with the same answer because you'll end up simplifying later on anyways. Righty, any questions about question 2? Are we all okay? Yes, no?
Let's vote, guys, with the thumbs up for that you're okay, or thumbs down if you're feeling unsure, so that Teacher Sam can see where we are all are. Masikiwa, I see you, I see you. Koketo, is that a hand to ask a question? I'm going to take your question while we are busy voting. Koketo, can you click on your side? Are you okay? Okay, so I'll take that as a mistake, okay? And if you do have a question, please do put it on your chat, or you can raise your hand again. Okay. Nice,
cool.
Guys.
So guys, just remember, all I did here was I added the like terms before I even started the equation just to neaten it up a bit. And then I saw that if I wanted to get just x on the left-hand side, I needed to use my opposite operation. So I needed to minus 5 on both sides in order to get x alone. So by getting x alone, I'm solving for x. Alrighty. So let's have a look then at question 3. And guys, a reminder, if you are new and you're joining us now and this is all a little bit overwhelming, just remember all of the videos are on the website, and so you can go and have a look there at this video, at this lesson, and all the previous lessons that we have done. Okay, so question 3 is quite similar to question 2. So if you didn't understand question 2, I would suggest maybe listening up here for question 3, and then hopefully question 2 will make sense. Alrighty, so question 3 is x minus 3x plus 9 equals 2 minus 3x. Now again, I can already see that on my left-hand side, x and minus 3x are like terms. So before I even start thinking about inverse operations, let me neaten this up for myself. If I say x minus 3x, I've got a negative 2x. And then I've still got the plus 9 equals 2 minus 3x. What I've done there by simplifying is I've cut down how many terms I need to work with. And so now all I have is minus 2x plus 9 equals 2 minus 3x. Now, whenever we've got x terms on both sides of the equation, so what I mean by that is if I have a look here, I can see that I've got an x on the left and I have an x on the right. Whenever I have a situation like this, what I want to try to do is get my x terms to the left. Okay, now this capital L just means left. I'm just being lazy. So get the x terms to the left. And what that then sort of means as a result is that we're going to get the constant terms, so the terms without a variable, to the right. Now, if you do it the other way around, so if you get the x terms to the right and the constants to the left, that's also absolutely fine. It doesn't really matter. But the reason I always say get your x's to the left is because when we write an answer for an equation, what we generally say is x equals some value. So x is generally on the left. And that's why I'm saying just get your x's to the left to start with. Okay. So what that means is, if I want to put all the x terms on the left-hand side, this negative 3x over here on the right essentially needs to move across the equal sign. The second I am starting to move terms across the equal sign, we now need to do our inverse operations. So this was originally minus 3x. So to move it, I now have to do the opposite and add 3x. Now I'm going to really do this step by step. You're welcome to combine steps if you are feeling comfortable. What I then have is minus 2x plus 3x plus 9 is equal to 2. So we can see now that that minus 3x has moved over the equal sign and it's now sitting on the left. And then remember, the other thing I want to do is take this constant that's on the left and move it to the right. And so I do the opposite. It was plus 9. I'm now going to minus 9. That's the only way I can move things over the equal sign is by doing the opposite operation. And so now I've got minus 2x plus 3x is equal to 2 minus 9. And now what I can see is that all of my x terms are on the left, all of my constants are on the right, and now I just add my like terms. So on the left-hand side, negative 2x plus 3x is then just x. If you want to write 1x there, that's absolutely fine. But remember, we don't have to write that coefficient of 1 in. And then on the right-hand side, 2 minus 9 is negative 7. And so x is equal to negative 7. Now, guys, remember, you always have that check. You just substitute back in and you can check your answers if you're unsure. All righty. So this was a little bit that we had to deal with here. So take a second, absorb it, take a screenshot if you need to, and then we can have a look at our next question.
Yes, guys, screenshot, shine is your time. When we take screenshot, we all shine, guys. We all do the shining thing. I see Christina already had the answer there. Well,
Nice.
Well done.
Oh, I've got
Kendra, are we following today? I see you, you're like sort of sitting in a distance, sort of a place. I hope you are following, Kendra. Faith, are you good? Are you following? So guys, I hope that everyone has followed, right? So I know that this class, you know, it's the first class. You guys are awesome. Woo, we're moving on.
Yes. Okay, guys, and like if you have questions, just pop them in the chat. Remember, okay, I'm more than happy to help. So let's have a look here at question 4. So we've got a negative 8x plus 2 equals 18. Now, in this case, I only have one x term and it's already on the left-hand side. So that's great. What I now want to deal with is the plus 2, because remember we spoke about the fact that we want to put all the constants onto the right. So this needs to essentially move. The only way for it to move is to do the opposite of its original operation. So I'm going to have to subtract 2. And so what that results in is me having negative 8x is equal to 18 minus 2. Now 18 minus 2, we can easily work out for ourselves. That is 16. And so we've got negative 8x is equal to positive 16. Now remember, guys, the whole point of solving an equation is to just have a value for x. I don't want that negative 8 there. I just want x. And so now we have to go back and ask ourselves, okay, what operation, and you can answer this for me in the chat, what operation is happening between the negative 8 and the x? Can someone, or can anyone tell me in the chat, or if you want to raise a hand, feel free. What operation is happening between the negative 8 and the x?
Yeah, Vince already is giving us an answer on the chat.
Nice, yes, exactly. Multiplication. All right. So if this is originally negative 8 times x, my inverse or my opposite operation will be to divide by negative 8. Now, guys, we need to be careful when we're dividing by negatives. I've got a positive 16 divided by a negative 8. And so when we've got a positive divided by a negative, we end up with a negative, and that 16 divided by 8 is 2. So my answer here for x is negative 2. So well done, everyone who said multiplication. Well done for dividing by negative 8 in order to get your answer of x equals negative 2. Nice, guys. Well done.
I think Mungezi wants to. Mungezi, do we have anything to say? Do you have a question? Is that to answer? Okay, I think we can move on. Mungezi, if you have a question, please do put it on the chat. We are all yours.
Awesome, guys. Well done. Okay, so, whoopsie. Let us now have a look at some slightly more complex examples. Okay, so now we're going to have a look at things involving fractions, things involving distribution, but there really isn't anything more challenging. As long as you remember your opposite operations, you'll be absolutely fine. I'm just seeing on the chat, Lesedi's asking if there's any other method. Lesedi, not any other method that's easier. So if you've got another method, please raise your hand and share with us. But this will be the easiest way to solve this specific equation. There are other ways to do it, but it does become a little bit more complicated. Alrighty. So let's have a look here at this first example here, guys, the slightly harder ones. So we've got 3x divided by 4 equals 9. Now, as long as you know what operations are happening in your equation, you will be absolutely fine. So when you've got a fraction, what we want to try and deal with first, and I don't know if you were here in the last lesson, we sort of ended off with a fraction sort of question. What we want to try and deal with first is the denominator, just because if we can get rid of that denominator, it means that we don't have a fraction anymore. And if we can avoid fractions, that is goal number 1. Now, that fraction is essentially implying that I'm doing a division. So that's the operation I'm working with. If we just consider the left-hand side, this is 3x divided by 4. So my operation that I'm concerned with here is division. The opposite of division is multiplication. And so what I want to do is I actually want to times by the denominator. So I want to times by 4. What that does is it essentially cancels away my denominator. But what I need to remember is to do that times 4 on the right-hand side as well, because remember, this is an equation. What I do on one side, I need to do on the other side. I need to keep my equation balanced. So now what I have is no fraction on the left, which is great. I've just got 3x, and then I've got 9 times 4. Can anyone tell me what 9 times 4 is? You can pop it in the chat if you don't want to raise a hand. What's 9 times 4? Nice, guys. Well done. Exactly. 36. Okay. Now, again, we need to remember the goal here is to get that x alone. So I have still got a multiplication by 3 that I want to deal with. And so what I do is I use my opposite operation. So I use division and I go and divide both sides by 3. And so what I end up with is that x is equal to 12. Because 36 divided by 3 is 12. Okay, and remember guys, you can check yourself. So just to quickly show you the check, if you want to check that your answer is correct, remember we substitute in. So all we need to do here is say 3 times 12 divided by 4, and we are checking to see that the left-hand side is equal to the right-hand side. Now we know 3 times 12 is 36. Oh, no, I don't want to put an equals there, sorry. And we want to then say 36 divided by 4, which is 9. And because 9 is equal to 9, your answer is correct. So you can always do a check with equations. Okay, grade 8s? Yes, are we feeling okay?
You can raise your hand or you can ask a question on where you get confused so that we can be able to help you, okay? We don't want to leave anyone behind, but you guys have to sort of ask the questions or put the questions in the chat so Teacher Sam can be helpful to you.
Okay, guys, the fractions are new and they are relatively challenging. So we're going to have a look at another fraction question now. So if you think, if you don't have a question, but you think another example might help, we are going to do one now. All right. Otherwise, please raise your hand.
Dealer's choice, guys. Let's do this. So you guys are fun because I don't see any hands. Okay, Mugezi. Mugezi to the rescue. Mugezi, ask your question. Mugezi, you will see that little pop on your device. You just have to click on it. It's like a little box that comes on your device. So just click on it to talk to us because you need to unmute yourself on your side. Okay, Mugezi, I'll put the questions on the chat.
Yeah. Okay, yeah, guys, if your microphone or the muting thing isn't working, then just type your question out and we can try help you that way. Okay. So let's have a look at question 2. So we've got 4 over 5x minus 2 equals 14. Now, before we even get to this, what I just quickly want to make quite clear is that whenever we've got a fraction and then a variable next to it, so like in this case, we've got 4 over 5x, this can be written as 4x over 5. It is exactly the same thing. Now, the reason I like to write it with the x in the numerator is because it just means that the inverse operations that I need to deal with are a little bit clearer to me. So if you prefer to write it like that, then by all means, if you don't, if it makes no difference to you, that's absolutely fine. So just so that you know, I'm going to write it with the x in the numerator so that I can be very clear on what my inverse operations need to be. So this would be 4x over 5 minus 2 equals 14. Right, now, if we want, especially if as we start to get more and more complex equations, I'm going to highlight where the x is. And that's just going to be to help me figure out what inverse operations I need to I need to work with. Okay, so the first thing that I actually want to deal with here is I want to deal with that -2, because remember, we want to get all of the constants over onto the right-hand side. And so if I can deal with that first, it means dealing with a fraction is a lot easier. So I know that if I want to move it over to the right, I'm going to have to do the opposite. So I'm going to have to +2. What that means is now I've got 4x over 5 is equal to 14 plus 2. And if you're happy to go straight to 16, that is absolutely fine. Okay, so we've got 4x over 5 is equal to 16. Okay, who can tell me, or who wants to be brave? Can anyone tell me what my next step would be here?
Come on, my people, we can do this. Remember, clue. The operation, guys, reverse operation. Let's do this. Come. Let's see.
Anyone want to try? Awesome. Okay, cool. So I'm going to have to deal with that division of 5 because like we said from the first example, I don't really want to work with fractions. Fractions aren't our best friends. So let's try and get rid of them. Opposite of division is multiplication. So we are going to times both sides by 5. That gets rid of that denominator. Great. No more fractions. And so now what I have is just 4x on the left. Can any brave soul tell me what 16 times 5 is in the chat? Or raise your hand. What is 16 times 5? Nice, guys. Awesome. Well done. 16 times 5 is 80. Okay. The next thing I now need to deal with is that 4, because remember what I want is x alone. I don't want 4x, I want x. So this now means that I'm going to have to divide both sides by 4 because it was originally multiplication. The opposite is division. And so then 80 divided by 4 gives me my answer of x equals 20. Well done.
Well done, my people. Entle, I see you. I see you. Well done, guys. Remember that it's time for you to just shine. Take your screenshots, ask your questions when we're busy doing that. Remember, we don't want to leave anyone behind. Mark it, guys. See where you went wrong. And hopefully you do your corrections. If not, Sam is here to help you.
Yes. Okay, guys. Right. So that is question 2. Again, completely understand this is still new. Some of this is quite tricky. Just keep practicing, just keep asking, just keep watching the videos. All right. So let's have a look at question 3. So we've got another fraction situation over here. So similar sort of thing to the first 2 questions. We've got 1 minus 2x over 3 equals 10. Now, just because that fraction is not the first term and rather the second term on the left-hand side, that doesn't really matter. That's okay. Much like we just did in question 2, what I actually want to first deal with is taking this +1, and remember, there's a plus here. We just don't have to write the plus, and essentially moving it over to the right, because remember, I want all of my constants on the right-hand side. So the opposite operation here is going to be to subtract 1 on both sides. And so what I end up with is minus 2x over 3 is equal to 10 minus 1. Okay, a couple things here. That minus sign that was in front of the fraction, all I've done is I've put it into the numerator. The reason being is because I know I'm eventually going to have to deal with that negative. And so if I can assign it its place, then I know where to deal with it. Because I've now put it in the numerator, I know that when I go and divide by the coefficient, I must remember to divide by a negative. And I would always put the negative in the numerator because it just makes life easier. Okay, so that's the first thing. Next thing is we've got that 10 minus 1. And if you're happy to go straight to 9, then that's absolutely fine. But we've got negative 2x divided by 3 is equal to 9. Okay, now this is sort of more familiar to us. First thing I want to deal with is the fraction, that division by 3. And so that means I need to use my inverse operation. So I need to times both sides by 3. That gets rid of the fraction, which is great. Don't like fractions, so I want to get rid of it. Leaving me with the minus 2x is equal to 27. Is everyone happy that 9 times 3 is in fact 27? If you disagree with me, you're welcome to say so. Okay. Can anyone tell me what I'm going to do next?
Yes, my people, let's do this. Let's tell teacher Sam what can she do next. Anyone who would like to talk to us, you're more than free to raise your hand. Okay, Mseki, I see you. Yes, my people.
Nice, guys. Right, so exactly, I'm going to have to divide, and I really appreciate the extra bit of information there from some of you that I specifically need to divide by -2. And that -2 is very important. If I don't divide the negative, then I'm not going to end up with an x. I'm going to end up with a negative x. And that's not what I want. I always want positive x. So I'm going to divide by that -2 because that's exactly what I end up having. I've got a positive x. Now, guys, just because I've got this weird, ugly fraction doesn't necessarily mean that I'm wrong. Okay. And as I said, you can always check yourself. You just go and substitute your x value back into x in the original equation. So sometimes we do just get fraction answers, and that's absolutely fine. Now, personally, I prefer improper fractions. Some of your teachers or some of your schools or you as a person might prefer mixed numbers, might prefer decimals. It really doesn't matter. It's completely up to you how you want to do it. It's really personal choice. So if you want it as a decimal, it would be -13.5. If you want it as a mixed number, we would have -13.5. All right, so it's up to you. I just personally don't like decimals and mixed numbers, so I always leave my answer as an improper fraction, but that's just a personal thing. Obviously, if the question tells you write your answer as a decimal, then you must do that. But if it doesn't tell you how to write it, then you can write it however you want, as long as it's simplified. Okay. Right, guys, can I just get a thumbs up, thumbs down? How we doing with this?
Okay, Christella, you have a question. Christella, we are all yours. Can you unmute on your side? Christella, are you able to unmute? Yes, I'm starting to think there's something wrong with this unmuting because no one can unmute and talk to us in this grade.
So weird.
Christella, are you there? Oh, okay. So nothing is wrong. Raise their hands by mistake. Okay.
No problem. Cool, no problem, no stress. Okay, guys, awesome. Well done. So fractions, we don't like. So get rid of that denominator by timesing it away. Alrighty. So let's have a look at question 4. So no fractions here, but what we do have is a set of brackets. And as I'm saying that, let's maybe take a break because we are half an hour in. I can see some very tired faces. So let's take our brain break here. Get up, stretch, move your body.
Yep.
Kendra,
Do
there's
this.
our stretch instructor.
Oh, nice.
Right.
So
Now, guys, this is just like a little brain break, brain teaser for you. You don't have to do it, no pressure. You essentially want to find the value of like the gummy bear, the lollipop, and all of those sorts of things. So get up, stretch, and if you want to have a try of it, please do, and you can pop your answer in the chat. Oh, and then my joke of the day.
Joke. Yeah, I'm laughing for the joke.
Kendra, no stretches today.
Kendra is feeling under the weather today, guys. I talked to him, I don't know how many times, and he didn't respond. Not even a single pinch. At least now he's laughing.
Yes, there we go.
Yes.
Oh,
Wendy, no stretch from you. Are you okay? Wendy's like, please, ma'am, I just want to focus on my math. Hey, Wendy.
that's fair enough.
Stretch from your side. There we go. At least there's some movement.
Hey guys, it is really important to move, because if you sit too still for too long, your brain actually just starts to not focus as well. And that's why it's like very silly. Even if you're doing exams and stuff, you should still be playing sports and going outside and doing things, because otherwise your brain just actually can't focus for an hour. It's just not possible. Okay. Anyone wanting to try the brain break maths riddle?
We can do it, guys. Try it.
And the point of these guys is just to sort of get like your basic operations more solidified, making you feel more confident with it, and a bit of problem solving, just like think a little bit outside of the box of what's happening here. Okay, so it's all with a purpose. We're not just wasting time. If you are stuck, I'll give you a clue and look at this step over here. It's saying that the bear is equal to the lollipop. Which will help you in the first step. Oh, guys, we're quiet today.
It's such a quiet class.
Is it just a Monday?
Yeah, Mondays are all like Mondays. But your joke really helped. I see Dondolo is laughing out loud, probably.
Crystal, I see that answer. I'm liking that answer.
We can, guys.
Anyone want to raise a hand and try? Otherwise, I'll quickly go through it so that at least if you are invested, you have the answers. No, okay, that's fine. Radio. So if we have a look at our quick brain break here, I gave you a little clue that the gummy bear is equal to the lollipop, which essentially means that when we are looking at this step over here, all three of those values are the same, because if the bear is equal to the lollipop, then it's the same number. So then we need to go and say, okay, well, 48 divided by the same thing 3 times is essentially asking us to work out what 48 divided by 3 is. And 48 divided by 3 is 16. So each of these is worth, or is 16, has a value of 16. Okay, good. Lesedi, well done. So now I know what the gummy bear is. So every time I see a gummy bear, I can chuck in 16. And every time I see a lollipop, I can chuck in 16. Now I need to go and figure out what the ring and the watermelon is. Now, in order to do that, I'm not going to go straight to the second one. What I'm actually going to do is I'm going to go to this third one over here, because this is a little bit of a tricky one, because it's saying whatever 16 is being divided by must give me exactly the same answer as what I divided it by. So I essentially need to figure out, well, what is 6, or what can I divide into 16 that gives me the same answer as essentially what the denominator is? And the only one it can actually be is 4, because 16 divided by 4 still gives me 4. And so the ring is 4. So every time I see a ring, I'm going to sub in 4. Then I'm going to go back up to that second one. And the second one is saying to me a watermelon times a ring is 0. Now we know if we're getting a product of 0, one of the things that I'm timesing has to be 0. So the watermelon is 0 in this case. And so if we now want to go and find the value of this final step over here, I've got 4 plus 16, which is 20, plus 0, which is still 20, plus 16 is 36. Okay, so this is a value of 36. Well done, guys. Nice. I'm seeing those answers coming through. Well done. Okay. So let's have a look at our questions here. So we're back to question 4. The reason I wanted to take a break was because it's a little bit different to our fractions. We now have some distribution that we need to deal with. Now, when we have an equation and we can see that there's a bracket or distribution that I need to deal with, that's the first thing I want to do before I start doing my inverse operations. If I can again simplify what's going on, it's going to make my life easier. So the first thing I want to do is I want to distribute that 3 into my bracket. Now, this is sort of back to simplification of algebra. When we say 3 times x, I get 3x, and 3 times positive 1 is positive 3. So on the left-hand side, I've got 3x plus 3, and the right-hand side, my 2x minus 4. Now, remember we said we want to try and get all of the x terms to the left and all of the constants to the right. So what that means is I somehow want to get this positive 2x over to the left-hand side, and I somehow want to get this positive 3 over to the right. Now, in order to do that, I have to use my inverse operations. I'm going to do this step by step. If you want to do it all in one go, that's absolutely fine. So if I want to bring the positive 2x over, I need to do the opposite. So I need to minus 2x. So that leaves me with 3x minus 2x. Sorry, got my x there. Minus 2x plus 3 is equal to negative 4. And then I still want to take that plus 3 and bring it over. So I have to minus 3. I have to do the opposite. And so I've got 3x minus 2x is equal to, oh gosh, so sorry guys, is equal to minus 4 minus 3. Now, if you are happy to simplify as you go, so say for example in this step, if you know that 3x minus 2x is x, you're welcome to write down x. You don't have to keep it unsimplified. I'm just doing that so that we can see all of our inverse operations. Now that my x is on the left, my constant's on the right, I'm going to add and subtract those like terms. So 3x minus 2x is just x, and negative 4 minus another 3 is negative 7. Right, so well done, guys. Those of you putting it in the chat, that's awesome. Well done. Okay, so when we have that distribution situation, we want to multiply away or out the bracket so that we don't have the bracket there. Okay. Princess, I see your hand. Can you also not unmute? Who knows what's happening?
Princess, are you able to unmute? So you just have to click that little button that comes on your side. Why can't my class unmute themselves today? Princess?
Okay, Princess, maybe try.
Yeah,
try put it in the chat and then we'll see if we can help you, okay? Oh, it was an accent. Okay. No problem. Cool, guys. So let's have oh golly, so sorry. Let's have a look at another example like this. So if we go over to question 5, we still have some distribution. We've got 2 times x minus 4 is equal to 3 times x minus 2 minus 2. So the first thing, before I even stress about solving my equation, is I am going to distribute. Now there's 2 sets of distributions that I need to do, one on the left, one on the right. And so that is where I'm going to start. Amatle, can you unmute? Do you want to ask a question?
Amatle, can you on your side? So you just have to click, because I'm unmuting you on my side, but you just need to click that button on your side. So we can have one person, just one person to talk to us today. I'll be so happy. are you able to do it? You can write on the chat if you are not able to do it. I'm not sure what's going on today.
Me neither.
There we go.
Yay.
There we go.
There we go, Matle, we can hear you.
Ma'am, can you hear me?
Yes.
Okay. Ma'am, I wanted to ask, with the previous equation, the one we just did, ma'am,
Okay.
I'm
Yeah.
confused on the last step, on the last step, ma'am.
This step, oh God, this step over here, where the arrow is, that's
Yes,
it.
yes, ma'am.
Okay,
Yes,
what's
ma'am.
confusing you about that?
I don't understand where, ma'am, I'm just so confused. I just don't understand.
Do you understand why I've said 3x minus 2x? Do you understand why I said minus 2x on the left?
No, ma'am.
Okay, so remember, once I multiplied, so once I distributed the 3 into the bracket, what I saw, and I'm just going to take my scribbles off here. What I saw was that I wanted to get this 2x over here. I wanted to get it onto the left-hand side. Because it was plus 2x, the only way for me to do that is to do the opposite, so to minus 2x. So that's why I've got minus 2x in the next two steps, because I've moved it over. The same thing has to happen with the plus 3. So I want to get that plus 3 over to the right-hand side. And the only way to do that is to do the opposite, so to minus 3. And that's why over here, in the step that you pointed out, I've got a minus 3 because I've moved it over the equal sign. And so the operation has to change. Okay.
So, ma'am, it will always move. It will always move.
Okay, I'm gonna say your network go.
Okay, Amatle, try type it in the chat because your sound is going a bit weird for us. Okay. Right, guys, so let's have a look at this question 5 that we were busy on. I'm hoping that you have been working on it. If we go and distribute, we've got, oh, why have I put in equals? My brain. I've got 2x minus 8 is equal to 3x minus 6. And then I've just got that minus 2 on the end. That wasn't being multiplied. I wasn't doing anything with it. It's just minus 2. Now I can start dealing with my inverse operations. Now, before I do that, what I do see is that in actual fact, this minus 6 and minus 2 on the right-hand side, I can simplify, so I can subtract those two. I'm going to do that just because it means I've got one less term to deal with. If you don't, it really isn't the end of the world. You should end up with the same answer. So minus 6 minus 2 is minus 8. Okay, so now, Amatle, hopefully you can still hear us. This is quite similar to the question you were asking, so hopefully this will help in answering the question in question 4. The first thing I want to do, remember, is I want to get all the x's to the left. So this 3, I want to bring over to the left-hand side. That then means I have to subtract 3x. It was originally plus 3x. The opposite of plus is minus. So that's the first thing I'm going to do. So I've got 2x minus 3x minus 8 is equal to a minus 8. Then the next thing I want to do is I want to take this negative 8, and remember I want to get the constants over to the right. So that then means I have to do the opposite and plus 8 on both sides. So that's going to then leave me with 2x minus 3x is equal to minus 8 plus 8. Okay. Oh, maybe I should put in my 3x. Sorry, I left off the variable. Right, now I can start adding and subtracting my like terms. So 2x minus 3x is a negative x, and negative 8 plus 8 is actually 0. Okay, so what that has resulted in is even with that -1 coefficient, so even with the -1 in front of the x, if I have to get an answer of 0, x has to be 0. If you're not quite sure why that is, I'm just going to go up here because I don't have space. What happens is we know we've got essentially -1x is equal to 0. Now, remember we spoke about the fact that I don't want a negative. I always want it to be positive. So I would divide both sides by -1 because that will then give me a positive x that I want. But we know that 0 divided by anything is still 0. And so x must be equal to 0. Okay, I'm just going to zoom out a bit in case you need to take a screenshot there. Right, now, sometimes when we get that answer of 0, we do have a bit of a panic, but this is why being able to check our answers is quite useful, so that when we do get an answer, we're like, oh, no, I don't think this is right. We can go check ourselves. Right, now, I see that there was a question of where does the 8 and the 6 come from? So quickly again, this 8 in the second step, which I'm just going to circle here, let's do it in this bright blue. This -8 came from multiplying the 2 and the -4. So remember, 2 times -4 is -8. Now, the -6 on the other side, so let's just do this. So this -6 over here came from saying 3 times -2, so the distribution in the first step. And then I saw that I had like terms over here. So what I did was I simplified it to get -8. So -6 minus another 2 is -8, right? So that's where those two values came from. Cool, guys. Hope you've taken your screenshots. Give you a second or two, and then I'm going to scroll over to question 6. Righto. Oh, okay.
We're doing this today. People, we are doing it. No questions, nothing. You guys are following. Well done.
Right. I'm going to ask that you try question 6. So remember, you've got a fraction. Actually, no, I'm being a bit mean by asking you to try question 6. Let's start it off together, and then I'll get you to a point where I'm going to say try by yourself. So question 6 is 3x plus 5 divided by 4 is equal to x plus 4. Okay, now, again, there's a lot of different options that you have here, but the first thing, remember, is if I can deal with that fraction and get rid of it, let's do it, because fractions are gross. So in the fraction, I'm dividing by 4, which means that to get rid of the denominator, I'm going to times by 4. Now, what's really important is that in the other questions, I just had one term on the other side of my fraction, and so I was just timesing by 4. But what I need to remember is I actually have 2 terms on the right-hand side here. And if I'm going to times the term on the left by 4, I actually need to times both the x and the 4 by 4, because that's going to keep everything in balance. If I only do it to one term, I'm putting my whole equation out of whack. So I need to do that multiplication to every single term in my equation, right? That's really, really important. So what that results in for me is no fraction on the left. So 3x plus 5 is equal to, and now remember, I'm timesing both the x and the 4 by 4. So x times 4 is 4x, and 4 times 4 is 16. So it's really important that you remember that if you're going to times the denominator, you need to times every term in that equation by the denominator. So in this case, by 4. If you don't do that, your equation isn't balanced anymore. And so you're not going to get the right answer. Right. From this point, I have faith that you can do this. So I'd like you to try and pop your answers in the chat as you go. If you're feeling really brave, I'd love to hear some answers. So you're welcome to raise your hand, and we'll attempt to get this working. But otherwise, pop an answer in the chat and let's see how you go.
Let's do this, my people. I can see Wendy is focusing. Well done. Moradi, what's going on? Moradi is like, oh, ma'am, Still trying to just see. Tando, I see you. Faith, are you writing it down? Nati, Princess, Keketo, Scarlett, guys, let's work. Sona, all of you, my people, let's try it. Let's try this question. Sekiwa, we see you, but you need to explain how did you get it? How did you get that answer?
Okay, guys, and check your signs. Make sure that you're taking into account all of the signs that you might need to double check. And remember, we always want X to be positive. So that's why I'm saying double check your signs. And if you are feeling brave, I'd love a hand raise so we can hear how you did it.
Yeah, Tando is just there with the family supporting her behind. Shout out to you, Tando. I see you. I see you. Well, let's do this.
I'm liking some answers I'm getting so far. Well done, guys. Okay, so I'm going to ask, would anyone like to raise a hand and give us an explanation? Anyone feeling brave?
Time to shine, my people. But if not, just then we'll continue because we're running out of time.
Oh, okay. Right, I shall have a look here. So I'm liking these answers. The only thing is I want signs double check. So when you're marking now, see where you might have gone wrong with a sign. So remember what we want to do is get all the X's onto the left and then the constants onto the right. So the first thing I want to try and deal with is getting this plus 4x over to the left-hand side, which means I have to do the opposite and I have to subtract 4x. So that is going to result in me having 3x minus 4x plus 5 is equal to 16. Then I want to get this positive 5 over to the right-hand side. So to do that, I use the opposite, so the inverse operation. So I subtract 5 on both sides. That leaves me with 3x minus 4x is equal to 16 minus 5. Now I've got like terms on either side, so I can add and subtract. So be careful here. 3x minus 4x is actually a minus 1x or minus x, however you want to write it. And then 16 minus 5 is positive 11. Now remember, I don't want minus x. I just want x. So I need to still deal with that minus 1. So I'm going to divide both sides by a negative 1. And remember, a positive divided by a negative is a negative. And so my answer here is x is equal to negative 11. So always just be careful that you're getting a positive x and you're not leaving negative sign there in front of that x. Okay,